Hey guys, I'm going to be talking to you today about one of the most important tools you should have in your toolbox as a programmer, and that is debugging. If you're taking this class at community college, for most people, including myself, this is probably the second or third programming class you've ever taken in your life. So it's pretty fair to say that you're still very new to the world of computer science, and because we are still so new to programming, it's very important that we not only learn the material that's being taught, but that we also develop good programming habits along the way. One of those habits that I think everyone should develop is how to debug your code. Debugging your code is a habit that everyone should be doing regularly in order to really understand what your code is doing. A lot of the code that we write in this class is fairly simple and it's not super complex, so you might feel like you don't really need to do this because your code is already running fine. But again, it's about developing good habits that will ultimately make you a good programmer. Maybe you've never heard of debugging before, just stay tuned and it'll all be explained. Debugging means going through your code, reading each line of code, and finding out exactly where in your code you have a problem or a bug. It sounds simple, but this will take up most of your time in programming. In Strustrup's book, I've read him talk about that as well. And if you're anything like me, you'll spend probably about 90% of your time debugging your code, looking at it, not knowing what is going on. But every time you go through this process of debugging your code, you learn so much more than before. So for this tutorial, I'm going to be using a software called GDB. And I'm going to be doing everything through the command line interface. GDB is a software that's used only through the command line, so you don't have, the nice graphical interface of something like Visual Studio Code. But if you wanted to do this in Visual Studio Code, you could as well. It's just gonna look different. It's exactly the same thing. It's more so the concepts of this that are important. So GDB stands for GNU Project Debugger. And it is a very powerful tool that we can use for debugging in C, C++, and a whole bunch of other languages. The biggest takeaway from this video is going to be understanding breakpoints and what they are and how we can use them to help us understand our own code better. So GDB is free software and it comes installed on most Linux systems already. If you're running Windows, then you're just going to have to install it yourself. The power server that we've been using in this class already has GDB installed, so I'm going to be logging into the power server from my own terminal at home and doing everything on the power server. GDB is not intuitive to learn. The commands are kind of weird, but once you learn it, it becomes very easy. And I am going to have a cheat sheet linked below, so check it out. Okay, so let's get started. I'm just going to start from scratch. This is my home computer. I'm just going to open a terminal. If you're on Windows, Linux, this is all going to be the same thing. Then let me make this bigger. Okay, so once I'm in my home computer's terminal, I'm just going to SSH into the power server. Okay, so now that I'm actually logged into the power server, I already have some code set up. So let me get into that. I have 4 files on here. And what I'm going to do is I'm going to open up this main.cpp file to show you guys what's in it. In this main CPP file, it's very simple. I'm asking the user to enter a positive integer. I'm storing that integer in the integer n, and then I'm going to see out the factorial, and it's going to go into this factorial function, which is in this factorial.h header file. Then I'm going to go into the factorial.cpp file, show you guys what that's about. Okay, so here we are in the factorial.cpp function, and this is just a function that will return the factorial of whatever number you give it. So what I'm going to do now is I'm going to compile this and see if it works. And okay, cool. Looks like it compiled perfectly fine. And here is our a.out file that it created. Okay, so I'm going to run this a.out file and enter a positive integer. So if I enter 4, let's see what comes out. Factorial of 4 equals 0. That doesn't seem right. So let me take a look at my code. So I'm opening up my code, and after staring at this for a while, I just can't seem to find the issue. So what can we do? We can use GDB. Let me exit out of this. Okay, so in order to use GDB, we're simply gonna recompile this, G++, tag G, using the same two files. And once it's done compiling, we're going to type the name of this a.out file. So gdb a.out. Simple as that. And so once you see this, you know that you're in GDB. The first thing that I like to do at this point is set a breakpoint. I'm going to get into what breakpoints are, but immediately after you see this screen, I like to set a breakpoint by typing break, and I like to set it inside the main function, so main. Okay, and then you see here breakpoint 1 at file main.cpp, line 7. So from this point, once the breakpoint is set, we can run the program. We can do run, or we can just type R. Both will work. Okay, so now we see here breakpoint 1 main at main CPP, and then here we have the line 7 cout. This is the line. Okay, so right now this may not look like a lot. You may be wondering, like, where's the rest of the program? From here, what you can do is press Control XA, and it'll bring you to this nice little GUI. So from here we can see that we have a breakpoint set at line 7. And what this breakpoint allows us to do is it allows us to step through each line of code individually and check the values of each of these things as we step through each line, instead of just compiling everything and running it and trying to see if we can find the problem by just looking at the code. We can actually step through each line of code. I'm going to show you how to do that. So right now the breakpoint is at line 7, and if I print the value of n, it's going to tell me that n is just, this is just what was already in memory, some random number. Okay, and if we step through to the next line of code, next, or we could just type n. So now we're at line 8. And line 7 has already executed. What this arrow means is that this line of code has not yet executed, but it's about to execute. If I press next again, it's going to ask me to enter a positive integer. I'm going to enter 4. And if you can see here, like this kind of like bugged out right here, this is pretty common in GDB. So to fix this, you're just going to press Control L. Anytime you see like this graphical interface kind of mess up, you could just press Control L to reset it. So now that we've entered 4, we can go back and check that value print, or just P, of the value n right here. Oh, so check it out. It's now 4. Before it was this because it was just some random number and we hadn't assigned it anything. But after we step through and hit next, we assign the value to 4. Okay, cool. Now we're on line 10. Again, this line of code has not yet executed. So what I'm going to do now, instead of pressing next to go down to the next line of code, I'm going to step into it, or just S. Okay, cool. Now we have stepped into it, and it's actually taken us to the factorial.cpp file. This is really cool. And so from here, we can start testing different values as well. So the first thing that we can do is, because we're at line 7, I can check the value of factorial right now. So if I print the value of factorial, I'll see, okay, this was set to 32767. This is just some random number in memory. And it's set to this because I forgot to initialize it. Ah, I see. Okay, so now let's check the value of I right here. PI. This is another just random number in memory, and that's because we haven't stepped through to the next line of code. So let's step through. And next. Okay, so now we've gone through line 7 and we have not yet executed line 8. So let's print I one more time. Okay, cool, and we see that it's initialized to 0. I can look at the value of factorial again and see that it's still this random number. So 32767. Okay, so if I step through one more time, let's check the value of factorial one more time. And now factorial equals 0. And that makes sense because we set I equal to 0 and then we multiplied it by this number, so we should expect to get 0. And at this point, I've kind of already figured out 2 of my problems. The first problem is that I set this I equal to 0 when it should be I equal to 1. And also, I never initialized this factorial. variable. And just a note, it's gonna, every time you hit next on this, it's gonna keep stepping through until it's done with this loop. And so once it's done, as you see here, it went to the next line, finally line 10 after this loop completed. And again, it has not yet executed this, but if we press next one more time, and actually if you just press enter, it will execute the previous command that you just did. So if you already hit next, if you already typed next, you can just hit enter. And look at that. Okay, so it returned us back to the main function, and see how here again it's all messed up. I'm going to press Control L again, and it's going to make it look all nice and pretty. So at this point we have pretty much already discovered what our problem was, but if we wanted to start over, we can just type R for restart. It's gonna confirm, and we're gonna press yes, and from here now we're back to where we started. And you can this is just a very basic starting point for using GDB. You can get a lot more complicated, a lot more complex. You can look at specific memory. It can get pretty good, but this is just the basics. This is how I mainly use it, these few commands. Once you've already kind of figured out your problem by stepping through everything, you can just press quit by pressing Q, confirm, yes. And then from here you can just go in and change your code to what we found. So I equals 1, change this to 1, and change that. So now if we try to recompile our code, and then run the same file, a.out, enter a positive integer 4. Okay, cool, we got what we expected, 24. And just to reiterate, this is just very basics on GDB. You can get a lot more complicated with this, and I encourage everyone to go out and try to make the most out of this.